Saxon Math Lesson 69. We're going to be dealing with proper forms of scientific notation. Scientific notation is a unique way of displaying really large numbers, but in a really small way. So I'm going to come down to the first one down here, and let's look at the easy one first, just to get our feet wet, okay? I have 1 times 10 to the first power. What is 1 times 10? Well, 1 times 10 is 10. And to the first power just means it's 110. Okay? So it's 10 to the only one time. So if I said 1 times 10 to the second power, it would be 10 times 10, which means 100. Or you can think of it this way. There would be 2 zeros. So if I added 2 zeros, 1, 2, it's 100. If it's 1 times 10 to the third, there'd be 3 zeros, so I could just add my 3 zeros and I would know that that's worth 1,000. So what about this one up here? And I put learning up here because that's what we're doing. So we already have 4,600. What more do we have to add? Well, this 5 says we're adding 5, 2, 3, 4, 5 more zeros. So if I put this into actual notation, that's 460 million. Okay, that's a big number, and we don't like to write those big numbers out. We like to put it out in a little bit smaller form. But what we're going to do is we're going to take this right here and we're going to put this into proper scientific notation because this still isn't correct. All right, proper scientific notation using the 4,600 example times 10 to the fifth power, we knew that as 46 million. Okay, and I'm going to put this up here, but here's what I want to show you. Proper scientific notation means that we're going to take this decimal and we're going to move it right here. So we only have one solid number showing and then the decimal. So it's now 4.6. And we're going to just cross off those zeros because they're not really necessary. But because we moved this 1, 2, 3, I kind of count them 3 positions, that changes this number. Okay, so because we moved it 3 positions to the left, we have to subtract 3. Excuse me, we have to add 3 because we moved it to the left. If we moved it to the right, we would subtract 3. So what's 5 plus 3? It's 8. So it's 10 times the 8th power because we have to make up for what that is. Okay, it's still this number, right? It's still 460 million, but we just put it in proper notation term, and this is proper term. Okay, so let's look at our example, and it gives us this number, example 1. Okay, and I'm on page 486 of your course 2 textbook. It says write 25 times 10 to the negative 5th in proper notation. So 25 times 10 to the negative 5th power in proper notation. So our goal is to move this decimal here. So now it's 2.5 times 10, and since we moved it from right to left, we're going to add 1. If we add 1 here, it's going to now be, it should be times 10 to the negative 4th, because 5 plus a positive 1 equals a negative 4, and that's what we represent. So the answer, 2.5 times 10 to the negative 4th power. How do I know that's still the same number? Well, let's put this out and let's go to the negative 4. Okay, and we're going to we can move it 4 places and we can come up with the actual answer. So again, this negative 4 and this negative 5 of 25 are correlated. They're both the same. Okay, let's look at one more just for the sake of it, for practice. Example 2. This time gives us a decimal, 0.25 times 10 to the fourth power. How do we write this in scientific notation? Well, now we're going to be moving from left to right, so we're going to subtract 1 from this up here, the exponent. So it's going to be 2.5 again times 10, and then 4 minus 1 is 3, and so this is our proper answer. It's all about just moving that decimal so that we have only one single digit and then all the decimals on this side of it, and then we have to change our exponent. Okay, so moving from left to right, we subtract. Moving from right to left, we add. If you can remember both of these terms, okay, or both of these rules, you will do fine in scientific notation. If you don't remember these, you're going to lose out big time. Okay, so a couple of problems you'll find in your textbook lesson with these scientific notation issues. If you have any questions, I'd be more than happy to help. Just let me know.